Hello, Coach Travis here with another pre-calculus video. So what we got here is a kind of a tricky graph transformation problem. So the idea is we're starting with the graph of y is equal to f of x, which is shown on this dotted graph here. And then I have this other graph that is a solid curve, and I can move it around. And my goal is to move that solid graph so that it makes the graph of this transformed version of the original function. So somehow, we got a bunch of, there's some algebraic transformations that happen to get us from the original to the new thing, and that is going to put into effect a sequence of transformations of the graph. And so we have to figure out how that works. Okay, so the way I always like to do these problems is I start with the original. So I start with my solid curve. Right now, here's what we're looking at. What we're looking at is the solid curve right here is the graph of f of x, because that's what the problem gave me. Okay, so now you might be wondering, why is the word wrong written here? Well, because, like I said, this is kind of a tricky problem. And there's a very common mistake that a lot of people make when they do problems like this. So, the problem comes from whenever there's a number or a negative sign right in front of the x. So if it's a flip across the y-axis combined with a horizontal shift, or if it's a horizontal stretch or compression combined with a horizontal shift, that's when things get tricky. So basically, whenever if there's a number in front of the x and another number inside of the function, then that's going to fall into this category of, I think, kind of a tricky problem. And so what I want to do is I want to make the common mistake. And so, because I believe that the best way to learn is to make mistakes and then understand why what you did is a mistake, think about why it doesn't work, and then figure out how to fix it. And then you'll never make that mistake again because you understand it. So I just want to warn you that I'm going to make a mistake when I do this, and then we'll figure out what the mistake is, and then we'll fix it, and then we'll get the right answer. So, okay, so I'm going to start with f of x. And so, all right, so what do I want to do here? So I want to follow this sequence of transformations algebraically. So if I look at what I want to wind up with, I see that I need to have a negative in front of the x. So, all right, so algebraically, the first transformation I'm going to do is f of x is going to turn into f of negative x. So I'm going to put a negative there in front of the x. And the reason I do that is because I know I eventually want to get a negative in front of the x, so let's do that. But now what I have to do is now I have to move the graph. So the graph of f of negative x is not going to look like this anymore. If you think about, well, what happens when you replace x by a negative x? When you replace x by negative x, what that's going to do is that's going to be a reflection across the y-axis. So a reflection across the y-axis means all the x-coordinates are going to flip sign. So right now the x-coordinate of this point is 1. So it's now going to change to x-coordinate negative 1. So all right, so now this solid curve is the graph of f of negative x. So it turns out that's not a mistake. That's if that makes sense to you, that's good, because it's correct. That's not where I made my mistake yet. Okay, so then let's see, what's the next thing I do? Okay, well, I need a negative 5 inside. Okay, so I say, okay, well, I need a negative 5. So I'll have negative x, and then I'll put a minus 5 there. And then if you think about graph transformations, you remember that, okay, when you replace x by x minus 5, that's going to be a shift to the right by 5. You know, when you put a -5 on the inside of the function, you get a shift to the right by 5. And so, okay, so we go 1, 2, 3, we shift right by 5. And now it turns out this is kind of where the mistake is. So if you're really sharp, you might feel like you might feel like there's something weird about what I just did. Or maybe if you've made this mistake yourself before and you've learned from it, you'll say, you know, Travis, I feel like there's something you did wrong there. But a lot of people, including myself, would say, no, this seems all right, because, you know, when you put a -5 on the inside of the function, it's supposed to shift us it shifts us horizontally, and if it's a negative number, it shifts us to the right, and if it's a positive number, it shifts us to the left. So a lot of this seems all right. So if you're feeling like this is okay, you know, I'm totally there with you. But it turns out there's a very subtle problem that's going to make it wrong. So anyway, let's keep going. And then finally, the last thing we want to do is we want to do the +4. Okay, so let's see here. So if I have my function is f of -x minus -5 and then +4, and then now we know that if you actually let's finish it. And then so let's see here. So that +4, when you add 4 to the outside of a function, that's going to be a vertical shift up by 4. So we move the graph up by 4, and there we go. Okay, so actually, yeah, so why don't I record in Word? I probably should have written some words here to say what we were doing. So what this did was this flipped us across the y-axis. Then what this was supposed to have done was this was supposed to shift, this shifted right by 5. And then the last shift was we shifted up by 4. Okay, so it's on the surface, other than Travis warning us that there's a mistake here, it feels like we did everything right there. But we can check. I have a feeling the computer, if we click submit, I have a feeling the computer is going to say we're wrong. So we click submit, and oh no, the computer says we're wrong. Okay, but it's giving us a chance to fix it. And so let's try to figure out where we went wrong. So it turns out where I told you where we went wrong before. It was right here in this step, right here. This maybe I'll put a red X by it. Or a star, I guess. This was the problem. And so the problem is that, actually, I probably shouldn't have erased. I probably shouldn't have erased the shift right by 5. Shift right. So we said that this was a shift right by 5, but it turns out it actually wasn't. So let's see. In order to actually, so here's the issue. Let me try to be clear about this, because it's kind of subtle. Is if you want to shift right by 5, then you have to replace the entire x by x minus 5. So what that means is that what's happening is then this negative sign gets in the way. Because notice what we did. When we did this, we just threw the -5 in there. And the negative sign that was affecting the x didn't affect that -5 at all. But if you really want to shift right by 5, then this entire x has to turn into x minus 5. And that means that this negative sign that is affecting the x has to affect the whole thing. The entire x is getting replaced by x minus 5. And so the negative sign that's there has to affect both of those things. So in other words, we need these parentheses. And then if you went ahead and distributed the negative, then you would wind up with this. So the moral of the story is what our answer is our answer is actually the graph of f of negative x plus 5 plus 4. And that's not what we wanted. We were supposed to get a negative x minus 5. So we actually wound up graphing negative x plus 5 because of the way these transformations work. Oh yeah, so let me cross out this wrong part then. Is now everything I have written here is true, but it gives us the wrong answer. So we algebraically we did everything right here. All of these algebraic transformations correspond to the correct the correct graph transformations. But as you can see, we wound up with not the answer we wanted. So we answered the wrong question. We did things right, but for the wrong question. Okay. So anyway, so now, well, how do we fix it? Well, some of you might see a shortcut to fixing it. You might say, oh, well, we could just work backwards. That is, we could, and maybe that's the easiest way to do this. We could just work backwards. So let me erase this. What we could say is let me get a better eraser. No, I need a much smaller eraser. What we could say is, okay, if we want a negative sign here, oh, and let me erase the words because the words might not apply anymore. If we want a negative sign here, and we do, because that's what the problem says, if we want a negative sign here, that means that we need a positive sign here. And then I guess there's no worries there because there's no positive or negative sign there, and then that's the original. So I think this might work. So now here's the sequence of algebraic transformations. And so let's record what do they mean in words. So the first algebraic transformation, what it means graphically is this, just like it was before. This is a reflection across the y-axis. So this is reflect across the y-axis. And okay, so all right, so we did that one right before. Okay, and now the next one, this was the one that was a problem before. So now what we have is when the x turned into an x plus 5. And so if you think about graph transformations, then when x turns into x plus 5, that's going to be now a shift left by 5. So that was what happened, is because we got the negatives goofed up, we actually shifted right when we were supposed to shift left. So, okay, so now we shift left by 5. And then the last transformation, that's an easy one. We just added 4 to the outside. And so that's going to shift up by 4. Okay, so we go up by 4. 1, 2, 3, 4. And all right, cross your fingers. I think this should work. And let's see. Oh yeah, it did. It was that one was correct. Okay, so let me see here. So I know this video has gone on a little bit long, but I just want to we've covered a lot of ground, and I want to sort of summarize it, and I want to show you kind of a more streamlined approach. So if I was actually doing this problem, if this was an actual homework problem, what would I do? I wouldn't make the mistake and then try to fix it. Although that is a legitimate way to solve a problem. So if you wanted to do this problem by trying to do it the wrong way and finding where the mistake is and fixing it, that's perfectly okay. But I want to show you another approach that might be a little bit faster. So what I recommend here is whenever there's a number or a negative sign right in front of the x, what I recommend you do is the first thing you do is you factor it out. So I'm going to factor out that negative sign. And so this will turn into negative x. And when I factor a negative out of the negative 5, I get a plus 5 and then a plus 4. So this is my target. So the idea is now I want to start, instead of thinking about my target function as this, I think it's easier to think about my target function as this. And now, of course, mathematically, these are the same thing. So mathematically, these are exactly the same. But for strategic reasons, it's easier to see what's going on when we factor out that negative sign. So the idea here is now I want to do a sequence. I want to start with f of x, and I want to wind up with this green thing down here. So the way I would do that is I'd look at it and I'd say, okay, well, let's see. I need to get a negative in there. So I need to have a negative x. And then let's see. Then what I need is I need to replace that x by an x plus 5. So I have f of negative, and then the x turns into an x plus 5. And then finally, actually, well, then I'll just draw a direct arrow. Then I take that and I add the 4. And so now that's algebraically how to get from f of x to what I want. And now I just record, well, what is each transformation? Well, this is a y-axis flip. This was to go from here to here. It was a shift left by 5. And finally, this was a shift up by 4. So, okay, so it's the same answer we got before. Everything is exactly the same before, but notice instead of getting it wrong and working backwards, what we did this time was we did that little algebraic factoring at the beginning. And so instead of worrying about this, instead of trying to get to this function, we wanted to try to get to this function, and that made it easier to see what was going on and what the correct transformations to use would be.